All right. So we finished up last time talking about we go through and algebraically restructure these multiplicative models in order to get to our simple slopes. Okay. Once we've gone through, run our model, created our interaction terms, and included those in there, at this point, you can go through and get your simple slopes for any sort of high or low levels of your moderator you want using just a little bit of algebra. I sent you that handout that will walk you through. If you're good on your algebra and you've got this under control, cool, just do it. If you're rusty, you haven't done it for a while, the steps that I'm giving you will help you sort of go down through and get to the right reduced equation. But remember, what we're going to do is we're going to drop down our intercept from here. Then we're going to grab our any terms that's not involved in our conditional effect. In this case, it's going to be opiate use. We're going to drop that down. And then we're going to section off, bracket off our two conditional effects. In this case, pain and PTSD both end up being conditional effects. And then we start going through taking my pain interaction and sort of my pain conditional, dropping those terms down and doing the same thing with PTSD, which is going to give us our restructured equation where we can go through and see impact pain on role functioning is going to be dependent on opiate use. Depending on what value we plug into opiate use, it's going to change on pain. It's going to start to change the strength of that association, right? So if we go through and we are looking at the condition high and low levels of pain, at high levels of pain, we take our restructured equation, right? We go through and cross out anything. We're holding everything else constant at 0, right? Opiate use isn't relevant, so we're dropping a 0 in there. That goes away. Here we're looking at high pain. So we plug in values for high pain, run that out, and it gives us our simple slope for the unique effect of PTSD on role functioning at high levels of pain, okay? Then we just do the same thing for low pain. We can start here, right, with our reduced model, go through, drop in low levels of pain, and then we get our simple slope for the unique effect of PTSD at low levels of pain, okay? Here, this coefficient for PTSD, this is our simple slope, okay? So here, high levels of pain, we have a what appears to be a small positive effect of PTSD on role functioning at high levels of pain. At low levels of pain, it looks like we have a moderate negative association. Now, these are all unstandardized coefficients, so who knows the actual magnitude of these, but this is a smaller number than this, okay? Same thing, we can go through and do the same thing with opiate use. For opiate use, here's our restructured equation. Go through, start dropping in zeros for anything that's not involved in this. PTSD is not involved in this conditional effect, so if you put 0 in for PTSD, that all turns into 0, right? So now we have our simple slopes here for no opiate use is going to be associated with a value of -5 in these data. We drop that in, get the simple slope formula for no opiate use. Same thing for opiate use, dropping the value of 0.5 in there. Remember, opiate use is the dichotomous variable. The only reason that high and low opiate use is 0.5 is because we got an even split. If you don't have an even split, it's not going to be plus and minus 0.5. Drop those in there. We get the simple slope for the unique effect of pain on, or the conditional effect of pain on role functioning for people who aren't using opiates, the simple slope or the conditional effect of pain on role functioning for people who are using opiates. Yeah. Yep, remember we centered those variables, right? And we're just taking standard deviation above and below. Another nice thing about centering, makes your calculations nice, right? You don't have to, but now all of a sudden, high and low levels of, let's say in the previous example, pain are weird numbers, right? Because I have to take the mean, the raw mean, and take a standard deviation above and below. It's weird. All this references to 0. So it just messes with stuff, okay? So that's where those are coming from. Yes. No, these, when did I say symmetrical? Yeah, they're just an even split. It's not going to be sort of the like 50, like half the sample has opiate is using opiates, half the sample isn't. Let's say I've got looking at difference in the ratio in the conditional effect of something on an outcome across men and women, and it's our typical sample where I've got 70% women, 30% men. It's not going to be negative 5 and 0.5, right? It's going to be that split there. Okay. So what we can do with this, with just your own brain and that main model, you can get to and start plotting out your simple slopes here. Okay. If we go through our interaction of opiate use and pain and PTSD here, we can do this in Excel just by plugging values in, and we can create these simple slopes graphs. Okay. Here we're seeing the interaction of pain and function for individuals who aren't using it than for those who are. And this kind of makes sense, right? If we got pain medications that's supposed to be helping people get by, we would expect pain to be more strongly linked to functioning if I'm not using pain medications. Less linked, still linked, but less linked for those individuals using medications. Here, we got a different interaction, right? Here we see individuals with low levels of pain. Severity is associated with kind of what we would expect with high just so low, right? If I'm high levels of pain, my functioning is floored out. PTSD doesn't matter at that point. Okay. All right. Quick look at these. Does anybody see anything wrong or problematic or questionable about with these simple slopes plots? Okay, yeah, so there's no variables on the x-axis, but x-axis is our role functioning variable. What's the range of role functioning in these data? What's the minimum? Yeah. Did we do anything with standard deviations for our output? No. So remember, we took the natural log of role functioning. Take the natural log of role functioning. What's the minimum value of role functioning that we can have? 0, right? Where's 0 fall on our y-axis here? Yeah. Here we have estimates that don't actually sort of map onto reality, right? We can't have on this scale, we can't have values less than 0, but we're getting estimates less than 0. Okay. This will happen, right? It's not necessarily a problem, but just know that, remember when we had talked about like, oh, when you're looking at this and you're like, oh, there's mean differences here and mean differences here and higher and lower levels and stuff like that. Not the purpose of these analyses. We're looking at associations between our conditional effect with our outcome at high and low levels of our moderator, right? So these aren't real points. These aren't observations that are actually in our data. These are model implied points. Based on our model, this is where we would expect functioning to be for people at high and low levels. So this is the association of PTSD and role functioning at high levels of pain, but we're below the floor here. We're actually lower than what we can be, right? Now, that doesn't mean there's anything necessarily wrong with your model. Again, it's just a side effect of having that weird outcome variable, right? So recognizing that that will happen. But the thing is we want to go through, and the same thing here. We've got for high levels of pain, point estimates for our model implied value for role functioning at high levels of pain is both, that point estimate is both below 0, right? If we took this out to, so high and low pain here is a standard deviation above and standard deviation below. What would happen if we took it out to 2 standard deviations? Now we're way the hell below 0, right? So recognizing that with these models, it's different than our means-based analyses where we're saying, here's the observed level for this group, here's the observed level for this group. Here we're working with model implied values, recognizing that these may hopefully do, but may not actually correspond to real values that you could have, okay? But the good thing is we don't care about the actual values because they're not real. What we can say is that, yes, it appears based on these analyses that PTSD has very little association with functioning for individuals with high levels of pain. And then we don't have to worry about we're just describing the association, right? But for people with low levels of pain, we're seeing a negative association between the PTSD and role functioning such that as PTSD increases, functioning also decreases. Okay, people kind of seeing what's going on with this. All right, so for plotting your simple slopes out in Excel, pretty easy, straightforward. What you're going to do, or what I would recommend you to do, is just go through, create a 2x2 table, and then use the computational powers of Excel to go through and get your actual points here for high and low levels. Here, if you have Y values that contain negative values, you can go and it'll do weird stuff. This is just how you go through and fix it. If you've got things flopped around, right, you can go to the top and hit switch rows and columns, and that'll switch things all around so that your model matches what you're trying to put out. But here is just a screenshot of Excel. So here for these simple slopes, right, I've got low pain, high pain, PTSD, high PTSD. And if you look at my field here, this is equal to 23.51 minus 0.42 times my value for low PTSD. If we for high values of PTSD, high pain is just going to be the simple slope for the relation between and functioning at high pain, plugging in low PTSD, same equation, plugging in high PTSD, and then we can go through and just plot that and set those up. Okay, so pretty easy, simple 2x2 table. Your formula here, or your simple slope equation, is what you're pulling out of just factoring your overall equation out. You're good to go. Okay, so based on just running that multiplicative model, you can go through, look at your interactions. You can determine whether or not you have evidence for moderating effects of your moderator, perhaps multiple moderators on the unique effect of your conditional effect on your outcome. You can go through, you can restructure that equation to look at your simple slopes. So you have got everything that you need just based on that one model, okay? Questions about what we've done here? Yeah, Amanda. This is mostly a problem because our role functioning variable is limited. It's actually not continuous. It's categorical. We did a natural log that kind of fixed it a little bit, but it's still got that floor. That's what's going on. So again, a good example of thinking carefully about your variables that you're choosing, your expected distributions and things along those lines. Okay. Other questions? Okay. So, we can get all this stuff just based on hand factoring, plotting, things along these lines, okay? And as we go through interaction term in our SPSS output, evidence for an interaction, that suggests that, yes, the conditional effect of X on Y does change across levels of your moderator, okay? What we don't get, though, up to this point, is the extent to which our data supported non-zero effects, whether or not we have evidence of non-zero effects of X on Y at high and low levels of our moderator, okay? If I go through and take a look at this, right? So here's my simple slope of PTSD with functioning at high and low levels of pain, okay? If I'm eyeballing this, guessing that it's for a negative between PTSD at low levels of pain, right? That looks like it's probably association, but I don't know how big that is, right? Or what the p-value is for that conditional effect at low levels of pain. Also, if I go through and I take a look at this, right, I could see a review. Oh, well, it looks like you actually have evidence for a positive association between PTSD and functioning at high levels of pain, because that's a positive slope, okay? Now, if we're know what's going on and thinking, like, what would be my response to that? Probably. If someone wanted to know, like, well, hey, is that indicating a positive association between pain and function, or PTSD and functioning at high levels of pain? What's that? Technically, you're right. Technically, we don't know that, right? I would probably look at that and be like, yeah, I don't know. It's never going to be exactly zero, right? So I would say that's, yeah, I mean, the coefficient is positive, but that's all the same thing as zero. But I don't know, and I can't state that with any level of confidence, right? So what we need is some way to go through and actually test these simple slopes to look at low levels of pain, at high levels of pain. What is can I get a test, a significance test, an inference test for that simple slope at whatever I decide are high and low levels of my moderator, okay? So the nice thing is, and this is where procedures developed by Aiken and West in that sort of very expensive, very thin paperback book that you've got there, sort of walking through this. What we can do is we can use our statistical software and sort of our understanding about centering and sort of what the 0 point in our regression models represent to kind of hijack that, to start looking at specific, the strength of association and specific tests of the association of my conditional effect on my outcome at sort of wherever I want to set that levels of my moderator, okay? So again, just to recap, what we've done is we've gone through, we've run our overall model, okay? We've gone through, we've restructured the equation, we've identified our simple slopes, we've calculated those out, we've gone through and plotted them. We've got everything that we want, except we don't have a p-value. I don't have a p-value for this. I don't have a p-value for this. And this can become important in many cases, right? So what we're going to do is we're going to go through and run 2 modifications of this model to start to be able to go through and tease out these specific tests, okay? What I'm going to do is I'm going to go through and I'm going to take whatever my moderator is, okay? And I'm going to go through and create 2 new variables that recenters my moderator at high and low levels, okay? And the way that we're going to do this is turned around, okay? In order to create high levels of my moderator, I'm going to subtract a standard deviation. And to recenter my moderator at low levels, I'm going to add a standard deviation, okay? So if I want to test the simple slope of PTSD on functioning at high and low levels of pain, to get high levels of pain, what I'm going to do is I'm going to take my centered pain variable, okay, and I'm going to subtract a standard deviation, which is 1.34. And then to get low levels of pain, I'm going to go through, create a new variable called low pain, and I'm going to add a standard deviation. And this is confusing and counterintuitive, and again, will be probably something you get turned around on, but it makes sense if we think about this graphically. So here we've got, let's say, a graph of our pain variable, right? It's a nice normal distribution. I've centered pain, and here's the 0 mark for pain. Pain in the 0 in my centered variable is equal to average pain, okay? If I go through and I run my descriptives on my centered variable, I've got a mean of 0, and I've got a standard deviation of 2.3, okay? And let's say that I am case number 23. I have a value of 0. I am dead center in the middle of the distribution. I have a 0 value of pain, which means that I'm right at the mean, okay? But let's say we go through and take this distribution and we go through and we subtract a standard deviation from everybody's scores to get to recenter our moderator at high levels of pain, okay? What happens is that in this at 0. But we went through and subtracted a standard deviation from my score. So we now took my score, it was 0, but now we went through and subtracted a standard, and I was at the mean, and we subtracted a standard deviation from everybody's score. So my new score is negative 2.3, okay? If I look at where my score falls on the distribution, I'm still at the mean, right? Because I'm at the mean of the distribution. But Matt, where is 0 now relative? Where's a value of 0 fall relative to me? Standard deviation above. So by subtracting a standard deviation, all of a sudden 0 is at the right tail of the distribution, right? If I go through and I subtract a standard deviation from everybody in there, 0 now corresponds to a level that's in the right tail, that's a high level, right? And so if I rerun my model, and my regression model is always giving me the unique effect of X on Y when everything else is held constant at 0. If we're holding pain constant at 0, what are we holding pain constant at? What's up? Going to be above the mean, right? 0 is now represents a high level, right? Same thing. I'm in my center distribution. I'm dead center at the mean, but this time we add a standard deviation to everybody, right? Go through, we add a standard deviation to, add a standard deviation to everybody. My score was 0 in the center distribution. We added a standard deviation to everybody's score. Now I have a score of 2.3. Where does 0 fall now, Sam? Standard deviation below. So if I run my model, and my model is always going to tell me, my model is always going to tell me the unique effect of X on Y when everything else is held constant at 0. That means pain held constant at 0 means pain at low levels of pain, okay? This is tricky, it's counterintuitive. We think about like, oh, high pain I should add, low pain, or high levels I should add, low levels I should subtract. It's the opposite, okay? Now, asterisk this, the only time that this gets tricky is if you're not centering and you have high and low levels and like sort of then you've got negative values, then that sort of, this is technically the formal operation. Pain is always negative this, pain or sort of your moderator minus a standard deviation above, pain minus a standard deviation below. It functionally ends up, if you have nice centered variables, you subtract a standard deviation to get high levels, add to get low levels. If you've got negative values, it starts to get tricky, but sort of this, you're going to be centering, so this will be okay. Okay. All right, so people see what we're doing, and this is, I can tell you, this is so valuable to know how to go through, because it doesn't matter what type, and I've used this for all sorts of different applications outside of moderation. If I want to know what my predictive model is going to tell me for a particular individual, all I need to do is just go recenter my variables to wherever I want that to correspond to, and that's who that effect is going to correspond to, right? So just recognizing all we're doing is just playing around with this and sort of setting where that moderator value is equal to 0 to go through and test those simple slopes effects. Okay. So if we go through and we do this, we've gone through, we've created a new variable in SPSS. You're going to have two new variables. You're going to have a variable that's centered, corresponds to high levels of pain, and you got a new variable, low pain, where 0 corresponds to low levels of pain. Then all you're going to do is you're going to create two new interaction terms, right? What you're going to do is you're just going to plug in previous in your original model where you had pain. Now you're just going to rerun the same thing. You're just going to substitute pain for high pain for the high pain model, and centered pain for low pain in the low pain model. And then you're just going to run new regression models with those substituted variables in there. Okay. So what we're doing is we're tricking SPSS into giving us tests. We're saying, I want to look at the unique effect of PTSD on functioning at high levels of pain. So what I do is I create a new variable, recenter 0, so 0 corresponds to high levels of pain, create a new interaction term, and then run a new model with swapping out pain in my original model for low pain in my new model, and then do the same thing for high pain, and then run through and just run those new models in SPSS. Okay, and if I do this, what's going to happen is I'm going to get we'll say we start with low pain. I'm going to get a regression model that has my where the variable that I'm using is my low pain variable, plus opiate use, plus PTSD times pain or opiate use times low pain, plus low pain times PTSD. I basically just went through and resubstituted low pain for any place in that equation that I had pain, right? And when I do this, what I'm going to get is this effect for PTSD is now my conditional effect of PTSD on role functioning at low levels of pain. Okay, we go through and I say PTSD on functioning, holding everything else constant at 0. Low pain is held constant at 0, that goes away, that goes away. Opiate use is held constant at 0, that goes away. Low pain is 0, that goes away. All I'm left with is my intercept and my simple slope. Okay. Same thing, if I go through and say, okay, I want to look at the conditional effect of PTSD on functioning at high levels of pain, cool. I just go through and anywhere I have pain, now I swap it out for high pain. So I've got my intercept times my coefficient for high pain, coefficient for opiate use for PTSD, opiate use times high pain, PTSD times high pain, right? And again, what I get out of that is I just got to look at that. That's my conditional effect of PTSD on functioning at high levels of pain. Because if I holding everything else constant, 0 here goes away, 0 here goes away, 0 here goes away, 0 here goes away, just left with my intercept and my conditional effect. Okay. So this is why I can't emphasize enough how important it is. You're like, oh, algebra stabbed me in the eye. But it really, really helps sort of make this sort of come together. It's going to start clicking when you start saying, what literally happens if I hold everything else constant at 0? That means holding things constant at the mean, things start dropping out. Okay. Or I guess here, we're not talking about holding constant at the mean, we're saying holding constant at 0, but now we've set 0 to be associated with low levels of pain or 0 associated with high levels of pain. Questions about what we've done here? Nope. This is all doing this in SPSS. Yeah, because remember what we need to do is we need to get tests of these effects, right? So if we go through and we take a look at our effects of centering, sort of going back through, if we're just looking at our straightforward first order models here, okay? Solution, here's my uncentered. Do we see any differences in these two models? No, we don't. We see one. Where's the one difference that we get? The constant. Yep. So this changes, right? Because again, remember our constant is the unique effect or sort of the expected value for our outcome. when everything else is held constant at 0, right? If the meaning of 0 changes, that's going to change my expected value, right? But otherwise, everything else is identical. Centering does not impact your sort of basic straightforward regression models, right? Like I said, we always interpret our regression coefficients as the unique effect of x on y, holding everything else constant at 0. But for our first order models where we don't have interaction terms, it doesn't really matter what we're holding our other variables constant at. It doesn't change the nature of those effects, except for constant, okay? But if we go through and we look at how our multiplicative, okay? So here, our model summary, our model fit, all that stuff, our test of the model, this is identical. Nothing changes. Centering doesn't change anything here, right? But if I go down and I take a look at my coefficients, now all of a sudden I am seeing things change, right? The intercept is different. My pain score is different. My opiate use is different. My PTSD total is different across these two, okay? What's not different are my interaction terms, okay? So if we've done this correctly, our interaction terms aren't going to change, our highest order interaction terms. Now, if you've got a three-way interaction, your set two-way interactions will change and your first order effects will change. Here, because our two-way interactions are our highest order effects, those are going to be remain constant. These don't change at all, okay? But if we're thinking about what's going on in these first order effects, okay? If I have an interaction of pain and PTSD, right? Depending on what 0 means in terms of PTSD, that's going to change the nature of that association. Even if we don't have evidence for an interaction term, it's going to change it some. Okay. Same thing, the unique effect of opiate use on outcome, holding everything else constant at 0. We've got an interaction with opiate use that's going to start to change the nature of that association. Same thing for PTSD total. Now, remember that we had talked about historically, one of the arguments for centering is that it reduces collinearity. Our interaction terms are a product of two of our first order terms, and so we get strong correlations there. If we go through and we take a look at your collinearity statistics, which one of these sets of collinearity statistics would you rather have, the centered solution or the uncentered solution? Yeah, why is that, Matt? Yeah, here we're getting variance inflation factors of 13.5, 16, 18.5. That should be like sort of big, huge red flashing lights in most cases. Okay, when we go through and we mean center, it goes through and it brings everything down into something that's much more acceptable. These are completely fine. These are horrible. Okay. Now, currently there's a debate going on whether or not you need the center or not. Is a huge difference, but if you actually take a look at sort of the impact on the model in terms of testing coefficients and things like that, it doesn't really make a difference. So even though the actual effect on the OLS model isn't anything that is consequential. And so you will see, particularly in some of Hayes's work, being more agnostic on whether or not you need to center or not, okay? I would say continue to center just because it helps interpretability, or at least take an intentional approach to centering, sort of thinking about what do I want 0 to mean for these variables, and then sort of going through and taking an approach. So for this class, we'll always go through and center, but in your later work, thinking about that. The other thing too is thinking about as you start to get into different frameworks, particularly within SEM, if you have this type of thing going on, you'll start getting non-positive definite errors and things along those lines that are going to screw up your models. So it does start to become important there. But know that you will see a difference in your collinearity diagnostic or your correlations and collinearity stuff in your centered versus your centered models. Okay. Other thing that's happening here, you'll see I crossed out your standardized effects. Technically, we'll talk about this in a moment, but technically your standardized effects, as SPSS will calculate them here, are not your proper coefficients. SPSS doesn't calculate these right. You have to do something a little bit different in order to get standardized coefficients for your interaction terms. So in just your base model, ignore the standardized coefficients for your interaction terms. If you want to go through and report those for a paper or something like that, which you probably will and should need to do, there's some additional steps you need to do to get the proper coefficients there. So ignore those. Okay. Questions? All right. Again, if we take and look at correlations between our centered variables and correlations in our raw variables, again, you'll see how centering reduces the collinearity. Here you'll see your sort of just straightforward correlations are all identical across the two. But when you start looking at correlations with interaction terms, these will start to change. Okay. So again, historically, the idea behind centering is to reduce that collinearity. We see it in the regression model. We see it in our correlation tables. At the end of the day, the impact for OLS regressions is not meaningful in terms of it's not going to ruin your model like we would expect that type of collinearity to do. But I would make an argument in terms of interpretability. It's still probably a good idea to do. It just makes things a little bit easier to work with. All right, finally, here is our centered equation. Here's our full model. Okay, went through the main effect or our sort of overall start model. This is the model where these are our coefficients that we went through and factored out, right, and got our simple slopes. Okay, but this is what's going to happen if I go through and I rerun this model. Centered pain for low pain. Okay, so here I've got low pain, opiate use, centered opiate use, centered PTSD, the interaction of low opiate use or low pain in PTSD and low pain at opiate use. This is our simple slopes model here. My base model is my constant has changed, right? But that makes some sense. This is the expected value with everything held constant at 0, where 0 is average levels of pain. This is everything expected value of role functioning. Everything held constant at 0, but now 0 is corresponding to low pain. And we see, as we would expect, better functioning if 0 is corresponding to low pain as opposed to high pain, right? You'll see that your interaction terms are the same here, okay? Your interaction coefficients didn't change at all, but we're getting different coefficients for your constant, for opiate use, and for PTSD. Your moderator, that didn't change, right? That's the same, right? But your conditional effects went through and started to change, okay? And remember that in this model, what is my conditional effect here that I'm interested in? What's the coefficient I'm most in? Why did I run this whole model? What do I want to? What's the coefficient or the effect I'm interested in here? PTSD, right? The unique effect of PTSD on role at low levels of pain, right? And here, if I look at the unique effect of PTSD at low levels of pain, and I go through and I take a look at my p-value, I've got a very low p-value here, right? If we went through and asked for part partial correlations, I would have effect sizes and things like that for the unique effect of PTSD on role functioning at low levels of pain, okay? So if I go through and run my high pain model, where I've gone through and I've substituted every instance of pain, centered pain for now high pain, I've now got a model that has high pain, centered opiate use, centered PTSD, high pain times PTSD, and high pain times opiate use as my interaction terms. And if I go through, once again, if I go through, so my interaction effects are identical. Those didn't change. My moderator, the coefficient for my moderator didn't change, okay? but I'm seeing differences in my other coefficients here. Amanda, what's the effect I'm interested in looking at here? PTSD again. So here, the unique effect of PTSD on roll high levels of pain is a very large p-value, 0.697, right? So what I can say, if I go back and I plot that out, right, I got everything except for those p-values and then the effect sizes and standardized coefficients and some stuff that we would want to report. But from my base model, just with algebra, I can tell you what the simple slopes. Basha, can you go back through to our, go backwards in the slides where we factored out and found what the simple slope of PTSD on functioning would be for high and low levels of pain, and tell me what we hand calculated. Okay, we're right there. Okay, this is so important with these models. There's just so many working parts. Always wanting to go through and double, triple check to make sure that everything squares to zero. This is maybe the most important slide of this whole lecture because it's giving you fail safes to know whether or not you did this correctly. Okay, if you've done this correctly, what you'll find is that you'll find when you go through and run your base model, you run your low effect or your low moderator, your high moderator, your interaction terms, your highest order interaction terms, those aren't going to change. Those are going to be the same. Your coefficient for your moderator is going to be the same. Everything else is going to change. Okay, so if you go through, you run your base model, and then you run your low model, and your interaction terms change, you've done something wrong. You got to go back through and check it, right? Or if you've got your moderator changing, that's weird. You have to go back through and check that, right? When you go through and you run the tests for your conditional effect at low levels of your moderator and high levels of your moderator, the coefficients that you get should be very close, if not identical, to what you just factored out of the base model by hand anyway. These are all ways you go through to double, triple check to make sure that what you've got is actually good. And if it's not, there's for sure something wrong there. Okay. Questions about sort of this step, this approach, what we've done with all of this? Seems like a lot, huh? Okay. What I would do and sort of sit with this and sort of go through, and as you're actually working through it, it's something that will, at some point it'll click and then things will start to fall together. What I would do is as you're working through this, whether you're doing this on a sort of a notes or in a syntax file or something like that, I would just write yourself notes like, this is what I'm doing. This is why I'm doing it. This is why this works. This is how I know if I've done it correctly. If you go through and do that, and then once you get a couple of these under your belt, you'll start to kind of get the process. Okay. All right. Let's jump in our actual SPSS file. So pull up and make sure that you have that moderation analyses worksheet that I had sent you. Not the screening, the output. This one right here. All right. So what we're going to do, we're going to go through, and this is data we've already screened. So, oops. Know that we don't have any weird values here. Okay. So what we're going to do is we're going to start by centering these data. Okay. So I'm going to go analyze descriptives, and I'm going to go through and Okay, so here we're just using role functioning, not the natural log of role functioning. So things will be a little bit different than what we had from previously, because we're just going to ignore the grossness of the outcome and just pretend that's not a thing for right now. But what I want to do is I want to look at my descriptives for pain severity, opiate use, and PTSD. And then I'm going to, you hit paste. I'm going to just go ahead and run this. Okay. And it's going to go through and give us our means and our standard deviations, our descriptives. Okay. So now what I'm going to do is I'm going to say, all right, I want to run and calculate centered variables off of this. Okay. So I'm going to go say C pain is equal to pain minus, and then I'm going to look at my score here. It's going to be 4.0702, period. And then EXE, short for execute. Okay. Now I've got my variable for centered pain. I'm going to go through, do the same for centered opiate use. I'm going to go opioid use, and here value is 0.5, and then my PTSD, take PTSD minus 50.9303. So what I've done here, oh, whoops, 0.5. So what I'm doing here is just mean centering my variables. Okay. City users, this is easier because you just hit M center and then list your variables and it'll do it all for you. SPSS, you kind of got to do this by hand. So you go through and run this. It didn't like any of that. What's up? Oh, yeah, that's what I did. I forgot. What's that? Oh, 50. Yeah. Oh, yep. Thank you, Elizabeth. Yes. So these are all the things that can go wrong and screw your stuff up. Okay. So we got 50.9303. Okay. That should be right. Nope. God damn it. Oh, forgot my period. Okay. Looks like calculating our centered variables will be the what? Oh, there it is. What's up? No. Yeah. It should, I'm just keep getting errors here. So, okay. That was a little bit of a struggle, but whatever. We've got our pain, our opiate use, PTSD variables. So now what I'm going to do is I'm going to go to analyze descriptives, and I'm going to get rid of all of these. And I'm going to look at my centered variables, look at descriptives here. And if I go through and I do that, I see that my mean values here should be very, very, very close to 0. Okay. Pain, PTSD is not exactly equal to 0, or those are sort of giving me 0 to 4 decimals. Opiate use is not exactly. That's just a function of sort of rounding error and things like that. If we go back through and actually hit the mean value, it's not exactly that. That's probably the easier thing if you wanted to just do sort of copy that in and drop that into your syntax. That just makes sure that it's perfect, right? But we're good here. Okay. So what I'm going to do now is I'm going to go through and analyze. We'll go through regression, linear. And I'm going to look at role functioning as my outcome. And we'll go through, just for the hey-ho heck of it, look at centered pain, opiate, and PTSD on there. We'll ask for not collinear. We'll ask for collinearity diagnostics, part and partial correlations. We'll ask for confidence intervals. We'll call that good. Okay. So if we go through and we run this, we go through and get our output here, right? And if we go through and take a look, what I've done here is just go through and take a look at your, just run this with your raw variables, your centered variables. And again, we're seeing that things are working out exactly like we would expect. The constant changes are intercept changes, but everything else is going to be identical across these models. Okay. People with me up to this point? Okay, cool. So now what we're going to do is we're going to go through, because we're not trying to run a first order model here. We want to look at some interactions, right? So we're going to go down through, and I'm just going to hijack this because there's a couple of interaction terms. What I'm going to want to look at is, make sure my notation here is got, we're going to go call it pain times PTSD is going to be centered pain times centered PTSD. And I'm going to want to add in opiate use times pain to pain times centered opiate. My stuff looks good here. Excellent. Nothing happened. Well, I don't have an opiate use by pain. Okay, there we go. All right. People follow me up to this point? So now what we're going to do is we're going to go through, we're going to go analyze regression. And what we're going to do is we're just going to drop in our two interaction terms here. Interaction of pain and PTSD, opiate use and PTSD. Go through and paste that in. Okay. Run this. And here we get a model that is looking very much like what we had gone through in our example. Okay. If we go through and I just pop this up so we can see, okay, what is looking at So this coefficient, Amanda, tell me what my intercept here is telling me. What's the interpretation of my intercept? Yep, it's my expected value, my model implied value, my expected value of roll functioning when everything else is held constant at 0, right? And in this case, everything else held constant at 0, I would say, if I wanted to elaborate on this and could, the expected value for roll functioning, controlling for opiate use and holding pain and PTSD constant at the mean, I would expect a roll functioning value of 10.038, right? I'm just literally plugging in what these different variables mean, right? We've centered opiate use. And so 0 isn't a real value for opiate use. It's either negative 0.5 or 0.5 in our data. So we're just saying we're holding that constant. But here we're holding opiate use and pain constant at the mean, right? And so that's our expected value, okay? Same thing. And if we go through and we take a look, Basha, what do we have in terms of evidence for our interaction effects? If we're like, what are we seeing here for pain times PTSD? Okay. Okay, go through and say what you're going to say. Okay, so this is where we get into a little bit of a tricky thing. Can we attach literal interpretations to these interaction terms? We can, it's just complicated, right? What this is reflecting is a change in the slope of your outcome per unit increase in things. Write that down, but start and say, don't worry about this, because I don't want you to have to, you don't need to try and slog through that. What we're going to do is we're going to run our simple slopes analyses, and then you can just look at high and low levels. Basically, if I'm looking at this, what does the interaction term tell me? What do we have in terms of evidence for that interaction? That we do. And so what does I say, Basha, I have an interaction of pain and PTSD. What does that tell me? Okay. And what does that, if I have an interaction, what does that tell me? What does it always tell me, Amanda? Yeah, that one depends on the other. Can we elaborate that a little bit more? What can we say specifically? If someone says, if anybody ever tells you that they have interaction of anything, what can we, even without knowing anything, what can we say? You know, Sam? That's the stock answer anytime, and it's reversible. You can switch that around. Say the effective pain, the association of pain on functioning is dependent on PTSD, or the effect of PTSD on functioning is dependent on pain. That's always going to be the answer. It doesn't matter what the interaction is, what's gone into it. If you say the effect of X on Y is dependent on sort of your M, that's always going to be the right answer, because that's always what this says. Even in ANOVA, right? We talk about mean differences, but really it's sort of the effect of condition on outcome is dependent on some other sort of thing, right? So here, because we have effect here, right? This is giving us evidence that yes, in fact, the effect of pain or the effect of PTSD on pain is dependent on levels of PTSD, right? Or the effect of PTSD on functioning is dependent on levels of pain. Sort of one of the two, okay? And we have here, we have our unstandardized coefficients, we have our p-values, our part and partial correlation, all fine stuff there. Sort of opiate use times pain. Basha, what does that mean? Perfect, right? Now here our p-value is 0.051, right? So I'm not going to make a big deal of thousandths of a point, right? This is not categorically different than 0.05, right? It's just weak evidence regardless, right? But our model is giving us some weak evidence for that the effective pain or the unique effect of pain on functioning is dependent on whether or not people are using opiates here, okay? All right, yeah. Yes, so what does then, Emily, what is this effect of PTSD? How would we interpret this? What's that? Yeah, so this is giving me the effect of PTSD on role functioning at what? Okay, did we do anything with standard deviations yet? Okay, so this is unique of PTSD on functioning at, okay, you're getting there, a mean of 0, but sort of what are your other two variables? Okay. Yeah, so this is the unique effect of pain on role functioning, controlling for opiate use, because 0 is not a real value there because we centered that dichotomous variable, and pain at what? What's our pain variable here? What did we do to our pain variable? What's the C at the front of it? Centered. Okay. And for our centered pain variable, what does 0 represent? Someone help her out? The mean, right? So if I'm looking at this in my base model, if I'm looking at this, I've got the unique effect of PTSD. This is telling me the unique effect of PTSD on role functioning, controlling for opiate use, and holding pain constant at the mean. Okay, because that's what I mean. Think about this as kind of layering on meaning, right? If I look at this, I can say, well, this is the unique effect of PTSD on pain, holding everything else in the model at 0, right? Well, what does holding everything else in the model at 0? Holding everything else at the model of 0 means that I'm controlling for opiate use and holding pain constant at the mean, okay? This starts to become important because when we're thinking about our simple slope graph, right? Where does the unique effect of PTSD on pain or unique effect of PTSD on role functioning holding pain constant at the mean, where does that line go? Yeah, right through the center. What we're doing here is in our base model, this is giving me the unique effect of PTSD on pain, on role functioning at average levels of pain. Okay. And if we go through and Matt, if we talk about sort of this coefficient for pain, what's this coefficient for pain represent? Yeah. Uh-huh. Perfect, right? It's formulaic. It's just the same thing, right? This is the unique effect of pain on role functioning, holding opiate use constant, and controlling for opiate use, and holding pain or PTSD constant at the mean. Yeah. Because our regression at the basic level, our regression is always giving us a unique effect of X on Y, holding everything else constant at 0, right? I get to decide what 0 means in my model. I've gone through and I've centered all these variables. So I know that 0 kind of controlling for it, right? 0 is not a real value in there. Elected not to center opiate use, then that would be if opiate use was equal to 0, then it's the unique effect of pain on role functioning for individuals who are not on opiates. Right? Yep. Yeah, that's why we're just saying we're controlling for it because, yep. Yep. Yeah. I mean, technically you are. It's just holding it constant at the mean doesn't mean anything. And so we're just saying we're kind of controlling for it, right? Yeah. 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 But as we'll see, we'll start playing around with that opiate use, that 0, 1 in just a moment. Okay. So the thing to remember is if I go through and I look at this with these interaction terms, if I don't have those interaction terms, does it matter what I'm holding everything else constant to? Nope. But as soon as I plug those in, this is letting these coefficients change depending on what the values of the other thing in the interaction are going on. And so now all of a sudden we have to be very, very explicit about what these mean. And this is why I've been so heavy-handed about knowing exactly what these coefficients are representing relative to the rest of the model. Okay. Questions about this piece? Yeah. Yep. Yeah. Yeah. We had to go through and calculate those interaction terms. Okay. Yep. And so this doesn't so you have to, in SPSS, you have to create your interaction terms. It's not going to do it for you. Okay. Stata, you can make it do it for you. Here you can't. And you have to go through and create those on your own. Yeah. Nope. This is your omnibus. This is your overall. You're not going in and doing anything on this yet. Yep. Yep. Exactly. Right. If you don't have evidence of any interactive effects, then you just say, yeah, we don't have evidence of moderation. And then that's the end of it. Right. Okay. But here we're going to say that we're going to call that close enough and go through and investigate. Okay. So what we're going to do is we're going to say, okay, we want to go through and first look at, here, I'll pop this back up. First, what I'm going to do based on this model is I'm going to go through and I'm going to hand calculate and restructure my equation and go through and calculate my simple slopes for PTSD and role functioning at low levels of pain and high levels of pain. Okay. This is just me going through and refactoring or restructuring that equation to go through. This is exactly what we did in class, right? And I'm just saying for this, Standard deviation of centered pain is 1.342. So we're just using plus minus there. Standard deviation for PTSD, 19.756, plus minus there, right? So we're just going through and plugging in high and low levels of pain and sort of restructuring that equation. Same thing as we did before with that restructured equation. I can plug in this into Excel and get my simple slopes graph, okay? But what I can't do is I don't have a p-value for the unique effect of PTSD on role functioning at low levels of pain, here operationalized as a standard deviation below. I don't get a p-value or effect size for the unique effect of PTSD on functioning at high levels of pain, here operationalized as a standard deviation above, okay? So what I need to do is I need to go down and start to create some new variables, okay? So for this, I need to go through and calculate high and low levels of my moderator, okay? So what I'm going to do is I'm going to go to Analyze, Descriptives, and I'll just repaste this, okay? I'm going to go through, run it, because what I want to get here is my standard deviations for my moderators here, right? And what are my two moderators in this model that I'm interested in? The way we've set it up, at least. What do you think, Basha? Opiate use and pain, perfect, right? So what I'm going to do is I am going to go through and create new variables. It's going to be called low pain, and it's going to be centered pain plus my standard deviation for pain is right here. I'll just calculate that out. And then what's slick about this, because it's centered, I go through and just copy it. Call this high pain. You can take centered pain minus the same thing. Now we've got high and low levels of pain. Okay. Same thing, going to go through and let's leave it at that for right now. So I've got my high and low levels of pain, but now what I need to do is I need to go through and I need to calculate new interaction terms, right? So I'm going to go calculate high pain times PTSD is going to be high pain times centered PTSD. And we're going to want low pain, right? Low pain times PTSD. And then I've got another interaction that involves pain with opiate use, right? Then I'm going to compute high pain opioid. So I'm going to high pain centered opiate use. Paste that in. Low pain. Low pain. And I think that does it. Yeah. Okay. People see what we've done here? We went through, because what I want to do is I want to test the simple slopes of PTSD use on role functioning at high and low levels of pain. So what I do first is I go and rescale my moderator so that 0 corresponds to low levels of pain, 0 corresponds to high level of pain. And then I go back through and I recalculate interaction terms, plugging in low pain, high pain for any sort of interaction terms where pain lies, right? And so if I go through and run this, okay, wonderful. And now what I'm going to do is I'm going to go through, and actually I'm just going to go through and grab my regression, my base model that I just ran. Okay. And then anywhere, so I've got pain. So what do we want to run? We want to run low pain or high pain first. Let's run low pain first. So I see in my model, I've got centered pain. I'm going to swap that out for low pain. Now I've got opiate use, PTSD, and then I got pain times PTSD. So I'm going to take low pain times PTSD and substitute that in. And then I've got opiate use times pain. I'm going to substitute that in for a low opiate use times pain. Oops. And there's my model. Okay. I'm going to take this, I'm going to copy this again. And now this time, it's easy. I just want to run high pain. Okay. High pain. High pain. Okay. So what I've got here is it's just following this sort of basic pattern. Go through and run high and low pain, or calculate my high and low pain variables. And this is the same variable, it's just kind of rescaled. Go through, calculate my interaction terms, okay? Corresponding to high levels of pain, low levels of pain, and then just substitute those back in for my base model that I already ran. Just anytime there's low pain or high pain, we just substitute those effects and corresponding interactions just back into the model, okay? And if I do that, and I go through and I run my low pain model, here we go, we get my effect of oops. If I go through and I run this, I get my simple slope or my conditional effect of PTSD on functioning at low levels of pain. And then if I go through and I run my high pain model, rerun this, and everything works out. This is what I get down here. Get my conditional effect of PTSD on functioning at high levels of pain. You'll see that my interaction terms didn't change. My coefficient for pain didn't change, but my constant, my opiate use, and my PTSD values all did change because we're moving around where pain is at. And each one of these other variables is dependent on pain. Because PTSD is in an interaction with pain, opiate use is in interaction with pain. So if I start jacking around where pain lays, it starts changing around sort of those coefficients. People see the process of how we go through and calculate these simple slopes. And then again, if we go through and take a look here, sort of for at unique effect of PTSD and role functioning at low levels of pain, we have very strong evidence here that we have an effect. But at high levels of pain, we've got a positive coefficient, but it's a really huge p-value that just means that there's fuzz there. There's nothing going on at that point, okay? But focusing on this really starts to emphasize the intent to look at the association between these variables, holding everything else constant, as opposed to if we're just looking at the graph, looking at kind of levels and difference between random points that sort of may not exist in reality somewhere on there. Okay. All right. Let's go through. Let's take 10 minutes. We'll come back at 3/4 till. Okay. Process this a little bit, and we'll jump into how do we go through and get at the simple slope for that for the other interaction term we have, because we want to look at the effect of pain on functioning for people who are and aren't using opiates, and that's a little bit different. So we'll get that when we get back. Okay, cool. You have a question? Oh, okay. All right, folks. So with that last step, so it sounds like some people got behind in terms of actually generating sort of the actual syntax. That's fine. Don't care about that. You've got all the syntax here, so you can go through and follow. Like people, so I'm not worried about that. You can go through and do that. But do people see kind of what we're doing, how we're actually setting these models and creating these models, and where we're going through and interpreting sort of the effects? Okay, cool. So what we're going to do then, so here we go. So we've got a model where we've got two interaction effects, right? And we've got evidence for both of these. Here we've gone through and run the simple slopes. We've gone through and done everything by hand here, right? Factored out, got all our slopes. Here, if we go through and we take a look at the conditional effect for PTSD at low levels and high levels of pain, they're functionally equivalent to what we've got here, right? Telling us that everything that we've gone through and sort of put together is good. The only thing that we get, or sort of the thing that we go through and sort of shift around our scaling here, is just so we can get p-values for the conditional effect of PTSD on functioning at high levels of pain, standard deviation above, and low levels of pain, standard deviation below. Okay. What we then need to do is direct our attention to our conditional effect of pain for people who are and who are not taking opiates, right? Again, what we did here is we just took our base model, factored that down, or sort of reduced that down, restructured our model to go through and calculate our simple slopes for the effect of pain on functioning for people not using opiates and for people who are using opiates. But again, what we need to do is go through and want to get p-values, effect sizes, and things like that for these slopes, right? We've drawn them out. We just don't have statistics for those, right? Outside of the coefficients. What's different about this interaction than the one that we did before? In terms of the component variables. Yep, opiate use is dichotomous. Okay, so when I'm putting together these base models, my approach, and this isn't the way you have to do it, but my approach is to go through and center that dichotomous variable, even though centering doesn't mean anything, or zero doesn't have an intrinsic meaning. It just, we say we're controlling for opiate use in this model. I like doing this because I don't know if opiate use is going to interact with anything, right? And if it doesn't, if I leave opiate use just as an indicator variable, 0, 1, what do the coefficients on my model then represent? Who do the coefficients of my model correspond to? If I leave opiate use at 0, 1. Yeah, then everything in my model is unique to people who don't use opiates, right? As I'm starting out, I don't know that I want that. And so I go through and I will generally center my dichotomous variables, just so it's sort of saying controlling for opiate use, right? But now what we need to do is we need to go back through and take a look and set up models so that we are looking at the unique effect of pain on role functioning for people who are and aren't using opiate use. So now we need to think about what are we going to do with this opiate use variable. Now, does it make sense to take our centered opiate use variable and subtract a standard deviation and add a standard deviation? Nope. This is a 0, 1 variable. We don't have to do anything weird with it, right? What I can do is I can just go through and create a new variable here, a new interaction that's just opiate use times pain using my original sort of 0, 1 indicator. And then what I can do in SPSS, if I go through and I say, here's opiate use, what I can do is I can just reverse code that. And there are better ways to do it, but I'll do it this way. I just go through and paste zeros into this new variable. Or I just went through and sorted by opiate use. So now everybody who has a 1 for opiate use in my new variable has a 0. And everybody who doesn't have opiate use, is not using opiates, now has a value of 1. So I'm going to call this new variable opioid R. Okay. And so if I go through and I go analyze descriptive frequencies, if I look at opiate use and opiate use R, they should be reflections of one another, and they are, okay? So now I've got 2 variables in my model where 0 corresponds with that dummy variable. In one of them, 0 corresponds to no opiate use. In the other, 0 corresponds to opiate use. So what am I going to do? How am I going to construct my model to test the simple slopes of the conditional effect of pain on role functioning for individuals with and without who are and who are not using opiates? Thinking about how these models are put together, how am I going to go through and achieve that? What do we think? So if I want to look at the unique effect of pain on role functioning for people who aren't using opiate use, what variable do I need to have in my model? Yeah. Yeah, what variable do I need to use for opiate use here? No. Well, we still need to have our interaction in there. What am I going to swap out? So all this is about just swapping out stuff. What's my new model going to be? Yep, it's just going to be my opiate variable, right? So what I'm going to do, my syntax file, is I'm going to create a new interaction term. And this is just going to be, we'll call it no OP times pain. And that's just going to be my original opiate use variable times centered pain. Okay. And then I'm going to have my other interaction is going to be, we'll call it yes opiate times pain. And this is just going to be opiate R times centered pain. And this is going to give me both of my interactions that I need to go through and test this. Okay. So I'm going to go through and I'm going to substitute in again for I'm going to go up and grab my base model. Okay. I'm going to grab this, drop this down. Okay. So what do I need to, Basha, what do I need to swap out as my predictors in this to look at the effective pain on role functioning for individuals who aren't using opiates? What do I need to swap out the predictors in my model? Yep. So I'm going to take my opiate variable. And so instead of centered opiates, I'm just going to put in opiate use, right? In my original opiate use variable, 0 equals people who aren't using opiates, 1 equals people who are, right? And then what else am I going to swap out? Okay, so which interaction term? Yeah, my opiate use times pain, right? I want to make sure that my first order effects match up to my interaction term. So I'm going to take that opiate use and pain and swap that out for the new interaction that I ran here. That's just giving me opiate use, no opiate use times pain here. Okay. And then if I want to go through and look at the unique effect of pain on functioning for people who are using opiates. Amanda, what do I swap out now for this? Yeah. So here we're looking at our first model is looking at people who aren't using opiates. Now I want to look at the simple slopes or this unique effect of pain on functioning for people who are using opiates. What do I swap out here? Yeah. Yeah. Just swap this out. My opiate R. Okay. So again, this is where it becomes so important to know exactly what 0 means, because if I know that, then I can confidently move back and forth and just change things around. What do I want to know? I want to know the relation of X on Y when this other thing equals this. Cool. I'll just recenter everything else to make that sort of correspond to 0. Now, in the first model, in the previous model, we had a couple of interaction terms that we had to go through and change. Do we have to fool around with PTSD and pain interaction here? Nope, why not, Basha? Okay. Yeah. Does this pain times PTSD, does that have anything to do with opiate use? No, it doesn't, right? So we don't have to worry about it, right? So this is what actually happens when working with dichotomous variables. So long as you know what those dummy codes mean, they're actually pretty easy to go through and play around with, because you just sort of recode them so that sort of 0 equals 1 or 0 is equal to no use, or 0 is equal to yes use, sort of whatever you want to do. And we can go through and sort of play around. So if we go through and we run our model here, looking at the effect of pain on role functioning for people who, and this is just my straight opiate use variable, where 0 is no opiate use, 1 is opiate use. And I go through and I take a look at my effect of pain, negative 12.347. If I look at my coefficient there, it matches up, right? If I go through and I run this for my recoded dummy, I get my conditional effect of pain is negative 7.744, negative 7, right? We're identical and back here, right? So if we're going through and taking a look at the results of this model, okay, I've got, for this, I've used just my raw variable, my original dummy code where 0 equals no, 1 equals yes. Again, my interaction terms don't change. My coefficient for opiate use, right? This actually does change because I reverse coded that, and so the sign switches. But other than that, it's fine, and that remains the same. But what we do see is we see a difference in my conditional effective pain on my outcome, depending on whether or not 0 means no opiate use, or whether or not I swap that around. So now 0 means that people who are using opiates. Okay, so I'm just playing around with what 0 means again, just this time with that dummy variable to go through and calculate my simple slopes, corresponding p-values, part and partial correlations, all that kind of comes together. Okay, Emily? Yep. And you absolutely should. I mean, I don't these days because if there's other stuff that's going on, I sort of know where to look for it and things along those lines. But for you, particularly for assignments, this is just a really nice way, one, to make sure that you've got it under control, and you can go down through and sort of make sure that everything squares up, because there are so many different ways to make mistakes in this, and you will. Like, it's just part of the process. But what you want to have is fail safes to be able to say, whoops, this doesn't square up. I made a mistake somewhere. What happened? Okay. Yep. 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 Okay. What are we trying to, what are we trying to, for our conditional effective pain, right? We had weak evidence for an interaction of opiate use and pain, right? So what is the logical sort of then goal there if I'm looking at conditional effects? What does that interaction of opiate use and pain tell me? Okay, no, so we got an interaction of pain and opiate use. And anytime we get an interaction, I just say, hey, here's an interaction. What does that interaction mean? Yeah, right. And so if I got an interaction of opiate use and pain, that's telling me the effect of pain on role functioning depends on whether or not you're using opiates or not, right? So how am I going to determine whether, tell the model whether or not, specify whether or not someone's using opiates? The model's always going to tell me the unique effect of X on Y when everything else is held constant to 0. So I just fool around with who 0 means. In the first model, 0 means people who aren't using opiates. In the second model, 0 means people who are using opiates. And then we just flip flop back and forth. What's that? It would be the same model. No, you just get, if you just, well, that's what this model is. Here, so basically, we're always wanting to look at what we need to do is we enter everything else so that we're looking at the effect of X on Y when everything else is equal to 0, right? So in this one, we want to effective, we're here, think about what we're wanting to know. We're wanting to know the unique effect of pain on role functioning for people who don't use opiates. A variable in my data set where 0 means people who aren't using opiates, it's my original opiate use variable. And so I just multiply opiate use times pain, substitute that in, and then my conditional effective pain is equal to the effective pain on role functioning for people who don't. Here, I don't have a variable in my model where 0 equals opiate use, so I made one. So now 0 does equal opiate use, 1 equals no opiate use. So I take my opiate R, recreate my interaction, and now my coefficient is telling me the effective pain on role functioning for people who are using opiates, right? This is weird because usually we don't have someone who's not using things, but for the I just sorted opiate use and then pasted in zeros for everybody who was using opiates and ones for people who didn't. If you encode it in syntax, it just yeah, because I created that in now. So yeah, I mean, what I did is this, like essentially is if you go through and you go insert variable, right? And this is then sorted. And I just put 1. For anybody who'd use opiates, and 0 for anybody who hadn't. So I just made it. Yeah. I mean, you can go through and recode, and you could have a sort of get that put together in SPSS with a recode command. It's just kind of a pain in the ass to type out, and I don't remember it off the top of my head how to format it exactly. So in SPSS, the nice thing is you can go through and do this. That's kind of the bad thing, because then I go through and start creating variables by hand that you don't remember how you did it. This is, again, sort of my lab sort of using sort of different, like Stata programming is nice because it's easier to go through and do it. And then I just have a list of what I've done. But yeah, that's all I did. And then just labeled that opiate R. And so this is always the way we're going to go through and handle these dichotomous variables, is just thinking about what does 0 mean, right? Because whatever group 0 corresponds to, that's going to be your reference group. That's what's going to, the whole model is going to refer to. And so Emily, that's why I went through and centered that dichotomous variable to start with, because I don't know if opiate use makes a difference or not. But if it does, I don't necessarily want my entire model corresponding to people who aren't using opiates. I would just rather sort of take the average of stuff. And so in my base model, we'll generally enter for those dichotomous indicators, we'll usually just center them, and then it just kind of holds it constant, right? But then if I do find that interaction, now I'm like, okay, I'm just going to rerun the model with my original dichotomous where 0 equals no opiate use, create a new variable where 0 equals does equal opiate use, make sure I have corresponding interactions, and just run them. Okay. What's that? Kind of, it's all about sort of your interpretations, right? I want my models to be maximally interpretable. Like if I wanted to go through and point out an initial coefficient, and this is like a lot of people don't. A lot of people don't care. They just like, oh, there's an effect or not. I don't know. There's more information to be drawn from that. And so just to start, I'll go through and dichotomize, right? Or I'll go through and mean center, just because now if it's just a first order effect, I don't worry about centering or mean centering my dichotomous variable, because it doesn't matter, because it's going to be the same no matter what. But another pitch too here, because these models are always giving you the effect of X on Y when everything else is held constant at 0. For regression, it's really not you. If I code my my dichotomous variable 1, 2, now 0 is not, and now it's not, right? So for dummy variables, 0 and 1 is always your best bet. And there are other coding strategies. You know, you can have code things -1, 1. There's like all sorts of different types of things, but it impacts the interpretation. This is just a sort of a nice kind of baseline to work with. All right, yeah. 0 is very important. 0 is what the whole model is based on. This is the effect of this variable on the outcome, holding everything else in the model constant at 0, right? Now, and then it's up to you to say, what does holding everything else constant at 0? For this, and this, it means the mean. For that, it just means controlling for it because it's a dichotomous indicator. And so we'll just go through. And what I want to know is exactly what these things mean. And so again, if you get into growth curve models or HLMs or sort of these types of things, that starts to become very important. So you just want to be keeping that in your mind. All right. So this is the walkthrough of kind of the SPSS, the whole procedure, right? We've gone through and done this, and you got your handout so that has like how we're actually getting this stuff in SPSS. You've got your slides that kind of walks you through conceptually what's happening, seeing how everything sort of marries up with this. You've got this recording from today where we walked through. I sent you some screencast videos of this example of just me talking to myself on working through an example. There's also another video, that second moderation, that'll work you through screening and sort of the same process using a different data set if you just want a separate look at it. So you've got lots and lots of resources at your disposal to go through and take a look at this. So also come to me if you're having problems with stuff. But again, get started on this problem set just because there's kind of a lot of, we only have to do one screening. Only going to ask you to do one screening on there, but just make sure you're paying attention to that. You may need some transforming on that piece of things. So just go through and make sure that you're attending there. All right. So couple more wrinkles. Okay. Remember that I had said when we had those slides up, I had the standardized coefficients for your interaction terms, had those all scribbled out. And I said, those are no good. This hasn't calculating these right? How SPSS goes through and calculates your standardized coefficients, right? Those beta values that you get. All SPSS is doing is it's going through and it's taking z-scores for all the variables in your model. So when you ask for and you request standardized coefficients, what SPSS does is it says, okay, Amanda is telling me to take the z-score of my my outcome variable and the z-scores of all of my IVs and just regress the z-score of the z-score of all of my IVs, and then that gives me my standardized coefficients. That's all it is. You're just rerunning your model. What SPSS is doing is just rerunning the model with z-scores instead of your raw variables, okay? So what ends up happening here when you go through in SPSS, what is it's just going through and regressing the z-scores of your outcome. Here would be the z-score role functioning times the z sort of regressed on the z-score of pain, the z-score of opiate use, the z-score of PTSD, that interaction term that you've created for opiate use and pain, and the z-score of pain times PTSD. Okay, and so that's your standardized coefficients. People see what's happening. Like you can literally recreate this if you go through and just take z-scores of all your variables and rerun a regression model with z-scores. It's going to give you your unstandardized coefficients in that model will be equal to the beta values that you ran before. Okay. Problem is if I go through, and so you've gone through an SPSS and you've calculated the interaction of opiate use and pain and PTSD, right, as the product of those two variables, and then it's going to give you a column of numbers. Okay. What SPSS is going to do is SPSS take the z-score of those numbers, but that's problematic because if I take the standardized that score, I can't sort of separate that out into its component parts. Actually, what's happening, the z-score of opiate use times pain, the z-score of that variable in my data set, is not equal to the z-score of opiate use times the z-score of pain. The z-score of pain times PTSD interaction isn't equal to the z-score of pain times the z-score of PTSD. The whole process with this algebra, remember with our interactive models, we need to pull those apart to be able to go through and factor them. And when SPSS and Stata or other programs go through and do this, they're not creating the appropriate coefficients for that, okay? And so what we need to do then, if we want to have appropriate interaction terms for our, or appropriate standardized coefficients for our interaction terms, is go back through and basically for what we did to create our first base model, we just have to do that again, but then this time just do it with z-scores, okay? So we just create a model where we had, in this case, we would go take z-scores of role functioning, z-scores of pain, z-scores of opiate use, z-scores of PTSD. And then I would create a new interaction term that was the z of pain and opiate use, where I take the z-score of pain and multiply it by the z-score of opiate use, and then a z-score pain PTSD, where I take the z-score of pain and multiply it by the z-score of PTSD. And so then I have to create those interaction terms sort of individually, like I did before. And then I just rerun a model where I've got the z-score of my outcome on pain, opiate, the z of pain, z of opiate, z of PTSD, and then the two interaction terms that I created with the multiplicative of that. Yep. Because what SPSS is doing is you created, for your base model, you created an interaction term for pain and opiate use and pain and PTSD. What SPSS is doing is whatever that number is, whatever that column of numbers, it's just taking the z-score of that variable. But the z-score of that variable isn't equal to the z-score of the one multiplied by the z-score. Those, I can't retrieve this from that, okay? And so what we need to do is go back through for those standardized coefficients is we just need to create a new interaction variable that's just the product of the two z-scores. And then if you go through and do that, then rerun your regression with the z-score, your outcome, onto your z-score for your base effects and your new z-score interaction terms that you created. Then what you've got is the unstandardized coefficients that you're getting in that. Those are just your standardized coefficients, because you've just manually restandardized. Everything else will be the same except for the z-scores or the standardized coefficients for your interaction terms. Those will be different than what you got with your sort of original model, and those are going to be your appropriate interaction terms. Okay. They'll be close, but they won't be exact. And the problem is, for those interaction terms, you need to be able to sort of deconstruct that back down into this, but the z-score of opiate times pain isn't the same as the z-score of opiate times the z-score of pain. So we just need to mathematically be able to factor those out. Okay. So a little bit of a pain, but not a huge pain. You just run in z-scores, create a couple. Basically, you just take your base model and just sort of substitute in z-scores instead of your centered variables, making sure that you got a z-score for your outcome, and then you're just going through and pulling that off, okay? And again, the important thing to remember is because you've gone through and manually standardized everything, your unstandardized coefficients, those are your standardized coefficients. If you look at the unstandardized coefficients of your manually standardized model for all your first order effects, your unstandardized coefficient is going to be the exact same as the beta value as you got in your original model, except for your interaction terms will be a little bit different. Okay. You do that, you put that in a paper, you look like a boss, and people just accept it because you know what you're doing. Okay. All right. Cool. Quick. Want to touch base on alternative ways to go through and think about is to go through, once I find an interaction term, or once I find evidence of an interaction, the interaction is telling me that the effect of X on Y is dependent on levels of my moderator, right? As the level of that as the value of that moderator changes, the effect or the the conditional effect starts to change around. And what we typically do in psychology is we just look at simple slopes at a standard deviation above or below. It's nice, it's standard. Everybody kind of knows what a standard deviation above and below is. It kind of puts everything just kind of on an even playing field where we just kind of know what's going on. There's nothing special about a standard deviation above and below. It's a little bit higher than the mean, it's a little bit lower than the mean, but there's nothing that is magical about a standard deviation above or below. It's just values at which we would expect people in our sample to fall at, based on our distribution, okay? This, because all we get when we run those simple slopes analyses is a measure of the effect of X on Y at two specific points. And if we're working with continuous measures, there's an infinite number of points we could run those simple slopes at. We've decided a standard deviation above or below, but there's all sorts of different places we go through and do that. And there, depending on the research question, there might be points along that sort of moderator that start to become more relevant than others, right? Not just a standard deviation above and below, right? And so what we'll hear this, people will call this a pick a point, right? So big, okay, here's a standard deviation above or standard deviation below, but it doesn't give us much information on at what point does X and outcomes stop or start being related to one another, okay? So if we go back through, okay, so here, if we say, our standard simple slopes analysis says that at a standard deviation of the sample PTSD doesn't have an association with functioning. At a standard deviation below the sample mean of pain, PTSD does have an association with functioning. But what's going on in between here? At what point does PTSD no longer have an association with pain? It's somewhere in between a standard deviation above or below, but there's no way to know sort of based on this approach. Something known as sort of plotting simple slopes at three different values, right? What we're doing is we're plotting out the conditional effect of X on Y. So we're plotting a graph of the actual coefficient for the unique effect of X on Y and corresponding confidence bounds across a range of our moderator. Okay. And so what we do is, this is sort of stuff I've set up in Stata. And give me iteratively the conditional effect of X on Y for values of my moderator from 0 to 9 at 0.05 unit intervals. So what this output is giving me the simple slope of X on Y at a value of 0 for my moderator, 0.05, 0.1, 0.15, 0.2, 0.25, 0.3, all the way until we get to the max value of 9. Okay, so what we have here in this p-value column is the simple slope iteratively in sort of 5/100ths of a unit interval across the full range of my moderator. And if I go through and plot this out, so here is, and this is from Layla's thesis. And so Layla, the relation between PTSD and social functioning at high and low levels of empathy, right? So does empathy change the nature of the association between PTSD and interpersonal functioning? We go through and we ran it, so it's yes, find an interaction of empathy, standard deviation above, really no association between PTSD and empathy. They're kind of unrelated. But for people with low levels of empathy, standard deviation below the mean, we get a negative association, whereas PTSD goes up, social functioning decreases, right? So this is informative. This is how we would normally present these data. And we would say, yes, the effect of PTSD on interpersonal functioning is dependent on empathy, at least based on these data, whereas data would suggest that we don't have evidence for an effect at high levels of for individuals at high levels of empathy, but at low levels of empathy, we get a negative effect, right? Problem with this is we're like, well, what's happening in between? Like at what point, like how much empathy do I need to have before we start seeing an effect of PTSD on functioning, right? And so what we can do, and here we've got our simple slopes, right? So at a standard deviation below, that's about an empathy. We've got a sort of, we've got a very strong evidence here, right? S and BFB. Here, standard deviation above, standard deviation above. Empathy corresponds to a value of 8. Here, we don't have evidence for effect. What we can do is we can plot this out as a Neiman-Johnson plot, right? Now what we have here are values of empathy ranging from 0 to 9. And on my X or on my Y-axis here, this is my conditional effect. This is my simple slope, right? And so we see at empathy values of 0, which I think no one got an empathy value of 0, but my model implied value of 0. At 0, sort of my value of empathy is, my conditional effect of empathy is large and negative, right? And here's my confidence bound, right? So I have evidence here. But as my empathy, the conditional effect of PTSD on social functioning, it's no longer, we no longer have evidence for an effect, right? So here, at a value of 3, that corresponds to this slope right here. We've got a coefficient of negative 1.3. If we go look at 3 on empathy, it's about there, sort of 1.63. 0 point, have evidence there. At a value of 8, right? In my simple slopes here, I've got a coefficient of negative 2.9. But here we'll see my confidence bound for that includes that 0 point, so we don't have evidence here, right? But what we can do with this plot is we can start going through and looking at other spots. But what about, if I'm eyeballing this plot, what about right here, right? About 6.75, right? That's kind of where that confidence bound just touches that 0 point. If we go through and we take a look at a empathy value of 6.75, our coefficient negative 0.63, and it's just barely tipping over in terms of evidence, right? But let's say, well, what about 6.15, right? Here, you can go through, take a look. What about a value of 6? I think this was the mean right here, 6.15. A value, start going through and looking at the conditional effect of exon across the full range, as opposed to just 2 points here, okay? I'm not gonna have you run this. I just want you to be aware of it. If you see it, this is what's going on. Instead of looking at here, X is your conditional effect, Y is your outcome. And here's slopes looking at the effect of PTSD on functioning at low levels of empathy and high levels of empathy. Here you have on your x-axis, and this is values of your coefficient, right? And so as your increases continually, we're seeing that unique effect, that conditional effect of PTSD on functioning gets around 6.75, where it stops becoming, we stop having evidence for an effect. And so what's cool about this, okay, like at what point does empathy stop being related to functioning? Or at what point does PTSD stop being related? 6.75, right? Once we get there, then that's where we lose evidence for an effect. But lower than that, we're good to go. Okay. People kind of see how this plot is playing out. Okay. This is starting to become more and more common. This is still kind of the standard, but this is a much more informative plot in terms of understanding the phenomena. We in this paper went through and presented both, which is still kind of a cool idea, I think, but just a different way to think about these conditional effects. Okay. How you do that in Stata, but if you don't use Stata, you don't care about that. So, okay. Last thing we're going to talk, well, second to last thing we're going to talk about here. What about a situation? So we went through and talked about an issue where we've got a dichotomous indicator, right? And we went through and talked about how we might approach that. But we can also go through if we have questions that involve categorical variables that have multiple levels. What we can do is we can start dummy coding this to incorporate those and start looking at things within a regression format. Okay, if we're talking about dummy codes, what we're talking about is what we're going to do is we're going to create variables in our data set where the number of dummy codes that we're going to have is going to be the number of groups minus one. And we're going to use this to go through and compare our subsequent groups with some reference baseline group or category. Okay. So if, for example, and this is straight out of Aiken and West, but it's a good example, right? Let's say that we wanted the effect of education and GPA or degree and GPA on starting salary, okay? And we're interested in whether or not eventually, whether changes the nature of the relationship between my GPA and my starting salary, okay? So what we've got here in this kind of small data set is we've got a variable, its degree, right? And you'll see here, this is coded 1, 2, 3. In these data, degree is equal to engineering degree is 2, business is equal to 3. Okay. Now I can't go through, this is a nominal variable, right? There's no order to these. This is just kind of how this is. And so I can't just plug that into a regression model. I mean, I can, it's just not going to give me interpretable results. But what I can do is I can decide to go through and dummy code this. And what this will do is start setting up comparisons between individual groups. Okay. So what we're going to do here is we're going to create, so we've got degree. How many levels to my degree variable, Elizabeth? 3. So how many dummy codes am I going to create? 2. You can calculate 3, but if you include all of those in the same model, you'll hit a collinear singularity problem and match world will implode on itself. Okay. So what we're going to do is we're going to create 2 dummy codes, 2 dummy variables. We're going to create a dummy code for English, wherefore in this set, anybody who is an English major gets a value of 1. Everybody else gets a value of 0. So if you're engineering. If you're an engineering major, you get a value of 1. If you're liberal arts or business, it's a value of 0. Okay. We're going to label this as dummy engineering. And then you're going to create a dummy code for business. Okay. Anybody who's got a business degree gets a value of 1. Everybody else not a business degree gets a value of 0. Okay. And we'll call this dummy business. Here we don't have a variable for liberal arts. Okay. But Basha, if I have in this data set, if my value for engineering is 0, and my value for business is 0, who am I? I'm a liberal arts, right? So this is why with these dummy codes, is you always have one less dummy code than the number of levels to your variable, because one of those variables, and you have to decide who's going to be my reference group. In this case, dummy for engineering, we've got a dummy for business. Liberal arts is our reference group, okay? So what we've gone through, taken that categorical variable and we've recoded it into 2 dichotomous variables, 2 dichotomous indicators, 1 for engineering, 1 for business. Liberal arts is our reference group. Yeah, you can make whatever. You just want to think carefully, who do I want my reference group to be? Okay. And that may change depending on your question, right? With this scheme, I can compare against engineering and liberal arts, and I can compare business and liberal arts. With this scheme, can I directly compare engineering and business? No, I can't, right? And so that's the limitation with this, wanting to think about how you're setting up these models. Okay. So if we go through and we do this, what we can do is, let's say I want to set up a regression model that's just comparing salary across these different degrees. What I can do is I can take salary and regress that onto my dummy for engineering and my dummy for business, and this is what I get, okay? And what this is going to do, if I go through and take a look at this, my intercept, this is my mean salary for liberal arts. Why is that true? Right? Again, just thinking about like the math always works out on this, right? Okay, well, if I'm a liberal arts major, then I'm a 0 on engineering, then I'm a 0 on business. Those go away, and what I'm left with is the intercept, which is just my expected value for individuals with liberal arts degrees. Okay, and if we go through and we plot that, that's just what that is, right? My beta 1 or my sort of B1 coefficient, this is just giving me the difference in my mean salary for engineering versus liberal arts. Okay, so again, if I have then I've just got my base salary, my reference value, plus an adjustment for engineering. So 699 or sort of $7,000. That's the added value on average for an engineering degree above and beyond liberal arts. Okay. Okay. Same thing if we go through, put that here. Here, my B, this is just the difference in mean salary between business and here, that's 0, that goes away. We've got my reference value plus an adjustment for business. Okay. All right. And my overall regression test here is just a test that salary of the null hypotheses that salary doesn't differ across my degree. Okay. What did I just run here? I did. Yes, that is the true statement of what I've run. Yes, it is a regression. What is it essentially, though? What's that? Yeah, it's a hypothesis test. What is this? What is the analog of this? If I just wanted to know if there are mean differences in salary across liberal arts, engineering, and business degrees, what would I have run? A one-way ANOVA. I just run a one-way ANOVA within a regression context here, right? My overall R squared, that's going to be equal to my eta squared. My F test for my R squared is going to be the omnibus test for the ANOVA. And my individual coefficients here are going to give me individual tests of the difference between engineering and liberal arts and business and liberal arts, okay? Like basically I've just run an ANOVA test within a regression environment with actually quite a bit more information than I would have gotten just running it as a one-way ANOVA. Okay, people see how we go through and do that. Now, I wouldn't, if you just have something that's a one-way ANOVA, I would recommend running it as a one-way ANOVA just because that's going to make more sense to people. But in this model, I not only got my omnibus test of are there differences, I also got 2 specific contrasts relative to a reference group that's already built into the model, right? So arguably considerably more information sort of in this, but it's doing, if I were to go through and were to run this as an ANOVA, as a one-way ANOVA, my eta squared from that ANOVA would be identical to my R squared from the model. My F value for my omnibus test would be equal to the F value from my regression model. It's the exact same thing. All right, so people see how we're playing around with these dummy codes to start looking at differences. All right, but here's something I can't do within ANOVA. What if I want to look of GPA on starting salary across different degrees, right? So what I want to know is how does my GPA in undergrad relate to my starting salary? But I'm like, boy, we've got different people getting different degrees, want to have that sort of included in there. So what I can do is I can just rerun this model, but now add center GPA as my predictor in there. Okay. So now I've got, here's my dummy, right? And if I go through and I run this regression model, here's the equation I get, right? Where 0 is going to be my mean salary for my liberal arts, right? At GPA equal to 0. And GPA equals to 0 means what? What's that? Hold constant at the mean. No one gets their degree unless it's from, I don't know, Spirit University Online. No one gets a degree with a GPA of 0, right? So that's not a meaningful question. But if we center it, now all of a sudden we've got things going on here, right? So 0, or this is our expected value for our expected salary for liberal arts degrees at average GPA. Okay. My B1 coefficient here, this is the difference in mean salary for engineering, and GPA difference in business and liberal arts controlling for GPA. And then here we've got our coefficient here is our expected change in salary per unit change for liberal arts. Why is this for liberal arts? Okay, close. Not held constant at the mean. If I have 0 here and 0 here, it just means I'm not a business major and I'm not an engineering major, so I must be a liberal arts major, right? We go through and we run this model, what we see is that it actually doesn't, effective GPA on starting salary actually doesn't matter depending on sort of what I swap these things out, right? Parallel lines, my values are different, right? As I go from liberal arts to business to engineering, things step up, but my slope doesn't change. Are we surprised by that? Sam, you're shaking your head. No. Why aren't we surprised? Why aren't we surprised that the unique effective GPA on salary doesn't change across these three? What's that? They all have a different intercept, sure. In terms of, in this model, they're not a degree starting salary and GPA. No, why not? See whether it, take a look at whether GPA, the effective GPA on starting salary changed based on different degree programs. What would I need to have in this model? Yeah, I need to have interactions. Remember, this is the same thing. My unique effect of X on Y to incorporate that change. So here, if I just have first order effects, I can look at on starting salary controlling for these three differences in these three, but it's all going to be the same, right? The slope is going to be identical across these. There's no way for this coefficient to change based on whatever I swap around here, okay? So what we're going to do is we're going to include interactive effects to look at the differences in the relation of GPA and salary across different degrees, okay? And if I bigger model where I've got my I've got my dummy for engineering, I've got my dummy for business, I've got my center GPA, and then I have an GPA in engineering, and then I have an interaction of business and, or excuse me, GPA in engineering, and then GPA in business. Okay. Do I have an interaction of business and engineering? No, because that doesn't make any sense, right? Do I center my dummy variables here? No, that doesn't make any sense. When we're doing these categorical, these dummies, those have to say 0, 1, because they got, or if it'll screw things up if you start screwing around with that. Yeah. Yeah, with it, if you have a true dichotomous variable, then I can center it and it just kind of takes it out. But here, yeah, I've got a category, like I've set up an indicator variable system where things have to be 0, 1 in order for the model to be interpretable. Okay. And so here, what's nice is that your simple slopes start to turn out again, this coefficient is my unique effective GPA on starting salary when everything else is held constant at 0. Well, what happens when everything else is held constant at 0? Who am I talking about? People with a liberal arts degree, right? So all falls out, and we just end up with 2982 plus my effect for my GPA, right? Here, though, if I want to go through and I want to look at my simple slope for engineering, again, what we start doing is just and holding everything else constant at 0. We bring down my intercept, my effect for engineering times 1 is just a number, right? So that comes down. My effect for GPA comes down. And then my GPA times engineering, I put in a 1 for engineering. That just comes down. And I've got my simple slope for engineering. My simple slope for business, same thing. Intercept comes down. My coefficient for business, that's a 1. That comes down as just a number. My effect for GPA, engineering times GPA, or business times GPA, I put 1 in for that. That adds up, puts that down, and we end up with our simple slopes there. Okay. What's nice about this is you don't have to worry about refactoring your model out. You're just literally putting in values for your different dummies. Okay. This is just the mean salary for liberal arts at average levels of GPA. Okay. B1 is the difference in my mean salary for engineering versus liberal arts when GPA is equal to 0. Now this is asterisk because depending on how we dummy code that can change around, but for this model, that's what's the meaning that's associated there. Same thing, B2, this is the versus LA when GPA is held constant. Here in B3, this is the change in expected salary in our liberal arts group, right? But only because liberal arts is set as the dummy or as the reference group here. The addition of coefficients B3 and B4, association between GPA and salary for engineering, right? And B3 and B5, association for business. So with this, it's actually, so long as you've got an understanding of what's actually happening, this is actually quite easy because all you need to do is just start dropping in values and you've got things that are good to go, okay? So if I want to go through, and so this tells me I can go through and create my coefficients and things like that and sort of map this out. But again, if I were running this as an actual model, I would want p-values, right? And maybe effect sizes. What I do is I just go through an SPSS and I just start swapping out who's my 0 value, right? So my simple slope for my liberal arts, this is just the test of B3 in my original model. We already have that, right? If I want to look at my simple slope for engineering, I just create a couple new dummy variables, one where liberal arts is equal to 1 and everything else is 0. Business, keep that same business, but this time, or still have a dummy for business, but this time business is equal to 1, everything else is equal to 0. And here we just rerun that model, test a B3 in that because now engineering is now my reference group. Looking at simple slope for business, same thing. I've got a dummy for liberal arts. I've got a dummy for engineering, right? And now I'm just going through and testing. This is tricky. You got to make sure you go through and change that. You can't use the same business dummy because that same business dummy had 0 for you got to make sure and sort of make sure that everything sort of maps onto things, right? So you got 1 for the target group and 0 for everybody else. but basically you're just going through and you're running that model again for everybody, right? And just looking at that effective GPA. So again, really simple, really easy. You're just kind of swapping out who the reference value is. And so this is, again, pretty straightforward if you recognize that the effective GPA on starting salary is just the unique effective GPA on salary when everything else is held constant at 0. What does it mean where everything else is held constant at 0? Who do I want to test this for? I just make them 0, and then we're good to go, okay? And if we do this now that we see, once we've gone through and done that, now we start to see differences in slope. We're seeing differences in levels, right? Because these are careers that have different sort of entry-level pay, but we're also seeing that here, was starting salary for people in business, a little bit weaker for liberal arts, and functionally no association for engineering, because if you're an engineer and you make it out and you pass and get C's, like you're probably doing okay, right? So again, what we're doing is we're just playing around with these dummy codes to go through and look at the association of categorical nominal variables on continuous outcomes and sort of looking at sort of the impact of that on continuous predictors and outcome. Again, once you understand the mechanics of what's going on with this, you can get super flexible and play around, ask all sorts of different questions, okay? Aiken and West talk about sort of different types of codings. So you have effect codings, right, where things are not 0 and 1, they're -1 and 1. Changes the interpretation a little bit, but dummy codes will probably work for you under most circumstances. Questions? All right. Today, one thing we want to be thinking about, if I find an interaction effect, right? Conceptually, I might wonder if I've got a strong correlation between my predictor X, if those two things are highly correlated, what we might be getting in that interaction effect is actually a possible curvilinear association between X and Y, okay? So if I have X and M are very close, if I take the product of X and M, it's probably going to approximate the square of X if those two things are very similar in nature, okay? And if I have a square function, parabola shape right here, right? So in Aiken and West, they go through and talk about procedures for looking at possible quadratic effects. A lot of this is going to be sort of, you can ferret out obvious stuff in initial screenings. There are procedures that you can go through and start to tease things up out, doing kind of some step down stuff. What you would do here in short would be having a model with X, M first order effects, and then the product of X and M as your interaction, and then maybe include a square term in there as well. Then start removing effects that you don't have evidence for to start to kind of tease things out. This isn't something that people think about a ton, but should be keeping in the back of their mind, particularly if you got a very, very strong correlation between your predictor and your moderator. Now, experimental folks, this probably isn't going to be as big of a deal because oftentimes if I'm working in an experimental setting, sort of these are all randomized, and so X and M can't be related to one another necessarily if I've gone through and sort of randomized people to different conditions. But for clinical folks, this can become an issue because a lot of the things we're looking at are sort of stacked on top of one another and pretty collinear. So something to be thinking about. And again, another pitch for going through and looking at screening stuff in terms of trying to understand sort of relations between sort of the nature of associations going on in my data. Okay, so if it comes up, Aiken and West have a nice chapter on this, talking about teasing this out. Definitely worth going through and taking a look at. All right. And effect sizes. within the context of these multiplicative models, okay? Remember, just as a review, when we're talking about effect size, we're talking about the magnitude of some effect within the population, okay? This is an unknowable value. It's a theoretical value, something that I guess in theory we could technically observe if we were to get everybody in the population and actually look at it, but in a practical standpoint, like we'll never ever do that. Think about your effect size, which I think is a really cool way to think about this. Your effect size measures the extent to which your null hypothesis is false. If I've got a small effect size, I'm saying, yeah, the null hypothesis is false to a small degree. Or if I've got a big effect size, the null effect is way off, right? Thinking about different types of effect size metrics depending on the analyses that we're running. Okay? Power, remember thinking about power is the long-term probability of rejecting the null hypothesis, right? If I were to do this over time, given this effect size, given this sample size, and this alpha level, like what percentage of these replications will I go through and find evidence for my effect, right? Well, what happens when we have our underpowered analyses, we're likely to fail to reject when the null hypothesis is false, right? There's an effect out there, we just couldn't claim evidence for it. Issue is when we're thinking about effect size, power, our moderation analyses are almost always going to be underpowered, okay? In psychological science, behavioral sciences, these interaction terms that we're looking for are generally not, they're pretty subtle, right? They're often not gonna be huge things out there, like with flares, like waiting to be caught, right? They're generally, particularly for the types of things that we're doing, right? We're testing theory, right? Matt's got a theory that says, well, technically, so the way this works with this mechanism, like this thing should change the nature of the association between X and Y. And this is how this process works. But it's maybe a more sort of conceptual theory-based argument than something that's sort of flashing out there with a big sign, right? And so the effects that we're looking at with these types of interactions are generally quite small. And what happens is sort of the issues that we have with power all the time in terms of just not having samples that are probably adequately powered to detect our effects. We also run into problems with measurement error and poor reliability with our interaction terms, okay? Thinking about, as a preview to these last couple of slides, if we think about the reliability of our measures, right? If we're using unreliable measures, at least in the bivariate case, what happens? What does that do to our estimate of our associations? If I'm looking at the correlation of X and Y, and I throw a bunch of measurement error in there, what's that going to do to my estimate of that association? Yeah, but it's going to bring it down. It's going to make it look like there's less of an association there because I've thrown a bunch of sand in the gears, right? What happens when we're looking at our interaction terms, because we're creating those interaction terms, is the product of two variables. The reliability of our interaction terms is equal to the product of our two reliabilities. Reliabilities range from 0 to 1. Generally, our reliabilities aren't 1. And what happens when I start multiplying decimals by one another? What do I get on the output? It goes down. So if I've got a reliability of 0.8 for measure 1 and a reliability of measure of 0.8 for measure 2, I multiply those two things together to get my interaction term. What's the reliability of my interaction? 0.64, right? Are we excited about reliabilities of 0.64? Nope. Right? So we took something that we would say has good reliability, multiplied it by another thing that has good reliability, and the result is something that has poor reliability. And then we're throwing that into a model, trying to detect a small effect with an interaction. The thing we're most interested in is sort of really poor reliability. And so now all of a sudden our power goes all to hell because of some issues there. Okay. So we'll finish up with this next week. Talk about from a practical standpoint in thinking about trying to run power analyses and plan for these types of analyses, like moderation analyses and regression, kind of the bread and butter of psychological research, like it has been for a long time. They're starting to get more complicated models. So we're looking at conditional indirect effects and things along those lines. But the thing to remember when we're going through how many people do I need in this sample to go through and adequately power this, the answer is always as many as you can possibly get, and that's still probably going to be underpowered. Okay, so just in terms of thinking about that stuff. All right, cool. Great job today. We're almost all the way through this. We'll pick up the last couple of slides here. You have everything that you need in order to complete this next problem set. Do you want the next problem set to be due this following Friday? Or do you want sort of extra time to go through and do? And I will tell you, here's the trade-off. If you say we want an extra cushion, extra week, things are going to get really compressed at the end, right? So this will give you more time to go through and get your stuff done, but it's also going to sort of start stacking things up here at the end of the semester. If we have them due next Friday, because you've got everything, I mean, there's a couple more slides, but that's won't impact anything that you're doing here. If we have it due next Friday, it's going to give you sort of less time to work on it, but it will also get the last big remaining set out of the way and sort of ease things up for the rest of the semester. That's fine. I mean, because it really makes no difference to me outside of people saying they want more time and then complaining about more time once they have more time because everything's stacked up at the end. That aggravates me. But I'm comfortable with what you, and also this doesn't have to be a thing. Like if everybody else says, oh, we want more time, but you're thinking, looking at my workload, I want to get this done. There's nothing that says in the universe that you can't turn things in whenever the hell you want to, right? Well, earlier than when the due date is. So think about that. Let me know. Yeah, so it's kind of a pay me now or pay me later, like sort of where do I want sort of the headache right now or at the end of the semester. So I trust you to sort of go through and take a look at your schedule, let me know, but you do have everything you need for that, for this next set, which is awesome. So regardless, jump in the middle of that and let me know. Okay, awesome. Thank you, everyone.